strip here, vertical strip, sorry, this is vertical strip, straight line here. Okay, this is straight line here, and this is vertical line. And if I divide this this horizontal strip, this is vertical strip. If I divide this whole region, okay, of this line, where line is, let me take x equal to, okay, let me write here. Here y is equal to, at this point, y is, or we can write here, here x equal to, or y equal to 0, because in this case if we divide into this region, here y equal to 0 in this case, and here y equal to 1 minus x. And in this, this horizontal strip, but we have x equal to 0 here, here x equal to 1 minus y, here x equal to 1 minus y. Okay, so that is what we have taken. Okay, now let me take what are the values here. So x equal to 0 to y equal to 1 minus x, and okay, and x equal to 0 to x equal to 1 minus y, and y equal to 0 to y equal to 1 minus x. The limits here at this point, the point is 0 to 1 limits. Okay. Here x equal to 0 at this point, and up to this x equal to 1. So we can take the limits here, y equal to here 0, and here y equal to 1. So limits can be 0 to 1, or if it is x0, then y equal to 1. Okay, so x0, y equal to 1 here, and at y equal to 0 in this case. The limits are, you can write 0 to 1 or 0 to 1. Those limits are there. Okay, this is what we have taken. Okay. So let me now find out what is the answer. So limits are 0 to 1, because this is 1, this is 1 here. So upper limits 0 to 1 in case of y-axis, okay, and this is 0 to 1 in case of x-axis. Coordinates are x and 1. Now let me take this. Okay, so applying this on this region, x plus y equal to 1. This is the straight line which is meeting x-axis and y-axis on point x equal to 1, y equal to 1. Even if we take x equal to 1 here, 0 here, 0 to 1 along the x-axis. If I take this vertical strip here, this vertical strip will vary from this point to this point. You go to this point, it will 0 in this case. Okay, and if I take horizontal, then from y equal to 0 to y equal to 1. This is how we can divide this whole region. Vertical strips or horizontal strips. The limits are 0 to 1 in both the cases, 0 to 1. Or we can write here, in the second case, 0 to 1 minus x here. If I write, let me write here, x equal to 0 to 1 minus. Okay. Here, y equal to 0 to 1 minus x. Y equal to 0 to 1 minus x. It means first we have to integrate with respect to y. Because in place of y only we can replace, we can put here this value 1 minus x in place of y. Okay. Then finally we will apply this limit. Then we will find out. So this is d.x. dy. First we have to integrate with respect to y, then with respect to x finally. Okay. In place of y we will replace x. Let me integrate this with respect to y first. So integration of x into y will be x is constant, y integration to y is with respect to 0 to 1 minus x. Okay, so this is 0 to 1 minus x. Now dx we will integrate, but before that we have to put the limits here. What is the limits? At 0 it is 0, but at 1 minus x, right, 0 to 1 x into 1 minus x whole square. Okay, into dx. Now let me first open this 0 to 1. Now integration of this will be, sorry, open, let me open this. This is 1 minus twice x plus x square into dx. Now if I multiply this is x minus twice x. 2x plus x. Now I have to integrate this. 1 minus twice x plus x square into dx. Now if I multiply this is x minus twice x. 2x plus x. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus twice x plus x square into dx. Now I have to integrate this. 1 minus t with respect to x, then apply the limits 0 to 1 limits with respect to x here. Okay, so this is here y equal to 0, y equal to 1 minus x. In that way we can apply, or we can first apply here y equal to 0 to y equal to 1 if I'm taking this origin to 1. But x, for x it will be x equal to 0 to x equal to 1 minus y, or 1 minus y, then we have to apply. In the end we can write here 0 to 1 minus y or 0 to 1 minus x. And initial value, I mean first integral sign will be 0 to, limits will be 0 to 1. 0 to 1, we have to apply it. What is the answer here of first integration? Then putting the limits. So integration will be x square upon 2, first one, and minus sign 2x cubed upon 3. Okay. Third one is x4 upon 4. Now limits 0 to 1. Integration 2x cube upon, so this is x into whole square of this. So now let me apply the limits here. At 1, at 0, everything will be 0. At 1, the answer will be 1.2 minus 2 upon 3 plus 1 upon 4. Okay, the answer is 4. I mean, LCM is, it may be 12, LCM is 12 here LCM is 12. Now this is 6 minus, this is 3 4 the 12, go to the 8 minus 8, and this is plus sign, 4 3 are 12 and 3, this is plus 3 9, this is 1.12 here, it is 1.12 here. Okay, the answer is 1.12 here. 1.12, any mistake here? No mistake. Okay, so this is x equal to 1 minus x. And if I take here with x into y only, first we integrated with respect to this and then with respect to y. So 1 minus x whole square first upon 2, I'm sorry, upon 2, why I'm missing here? I'm sorry. This 2 was also there. Okay, I'm sorry. The 1.2 was also there. It's 1.2, I'm sorry. X into 1 minus x whole square, undoubtedly, but upon 2 was also there. This is upon 2, 1.2. Finally, this is 1.2 also, that means 1.24. This is 1.2 into this, so it is 1.12 into 1.2 multiplied. So this is giving us 1.2 equal to 1.24. Now this goes. The answer is 1.24. Area, I mean this integral sign, integral value of integral is 1.24. Sorry, because 1.2 I left here. 1.2 was, okay, mistaken. That was I left here. This 1.2, 1.2 is further multiplied to 1.12 into 1.2. That means 1.24. The answer is 1.24. This is question number 3 here. This is answer 1.24. Okay, so now question number 3 we are done. And let me talk about 4th question. Now, it could be done in other way also. We could take the y limits, or the x limit, x equal to 0 to 1 minus y, in the end, and then 0 to 1 for y. So in that way also we could do. Same answer will be obtained. That's not a matter of discussion. It can be done in that way also. Now let me talk about question number 4 here. What is question number 4 say? Question number 4 say when the region A of integration is a triangle be given by y equal to 0, y equal to x, and x equal to 1. No problem. Okay. Then show that this integral sign d.x.d.y equal to this. Okay. First let me. Okay, frame the triangle. Okay, so sorry, this is x-axis, origin x dash, and y dash axis. This is coordinate axis. Okay, x and y axis. or double integral. Now, what is the triangle that we frame? It says that when the region of the integration is the triangle given by y equal to 0, wherein y equal to 0 at x equal to x-axis here, at x-axis y equal to 0. So x-axis is involved, means it means one of the sides of the triangle is x-axis. Alright, x equal to y equal to 0. So y equal to x here, y equal to x is the line, is a straight line which passing through the middle part of this, making 45-degree angle. It's 45-degree angle, okay, or pi by 4 angle here. So this is 45 degree. At 45 degree, going to the middle of x and y axis. This is y equal to x line. Is a straight line which is passing through the origin, and in the middle of x and y axis is passing through. This is y equal to x axis says. So y equal to x, then x equal to 1. Now x equal to 1 maybe here x equal to 0, x equal to 1 is here. Let me take x equal to 1 at this point. This is at x equal to 1. X equal to 1 here. This is the straight line which is passing through this point where x equal to 1. This is x equal to 1. This is x equal to 1 here. What is y? Y is also 1. Here y is also 1. Because if I substitute here x equal to 1 at this point, so this line is cutting this y equal to x axis at y equal to 1. Your point there is 1 and 1. This is coordinate for this. Okay, so now if I take again a straight line, what is this? What is the double integral sign that is given there? What are the limits here? 0 to 1 for x coordinate, and y is also 0 to 1. So the limits are 0 to 1, 0 to 1. What are the points there? Okay, now let me take that region. So this is the region here. Let me take this region like this. This is the closed region. And if I take a strip like this, a rectangle, or sorry, vertical strip. This is the vertical strip, and if I take this area, this is d.x.d.y, defined by small area d.x.d.y. Because this strip is from 0 to 1 for x-axis. For y-axis also, this is from 0 to 1. Okay, this 0, and at this y equal to 1. So that is for x-axis also. Now let me take that what is the answer of this question. We have to prove that is there. Because first integration, so this question number 4 here, it says in double integral sign or double integration or multiple integral. A here, what the square root? It is 4x square. Sorry, it is 4x square minus y square into dx dy, type 1 addition. Okay, and what are the limits here? The limits are, for x it is 0 to 1. Okay, and first have to integrate this with respect to y. For this is 0 to 1 for x coordinate, and for y it is y equal to 0 here, 0 to x. yx region is y equal to x. At that point, for this line, okay, y equal to x is there. Okay, so first we have to integrate with respect to y, and then we will substitute in place of y and x, and that will give us. So this is the value here, 4x square minus y square. Okay, and this is first is integration with respect to y, then we will integrate with respect to x finally. For x, these limits are 0 to 1. First integration is for y equal to 0, y equal to x. So this limit is there. Y equal to x, we can substitute finally the limits. But in place of x, we substitute final limits, so answer will be, the final answer will be there. What is that answer? Let me check it. Now what is the integration of this? Now this integration we know. First let me integrate this with respect to y. Y here is the variable. and this x will be constant. This is twice x whole square, or a square minus y square under the square root. Integration of this will be 1 upon 2, okay, into y, or we say x upon, if x is the variable, a square minus x square, will be x upon 2, which is y here, square under the square root, the same value, 4x square minus y square, it comes out to be repeated one, plus sign, then a square upon 2, that means 4x square upon 2, this is the middle point, into sine inverse, because this is under root 1 minus a square, or a square minus, this is sine inverse of y upon 2x, x upon a, this is the complete integration of this whole. Okay, now these limits are 0 to x less than, first substitute here, 0 to x limits, then dy per dx. So first, apply the limits here, 0 to 1. At 0 it will be 0, because that when y is 0, so here y is to be replaced by x. So this is 0 to x here, limits are 0 to x, y equal to x here. So 0 to x is for y, variable y. In place of variable y, we have to put x. We have to put x here. What is the value, first find out, then we will, whatever value left over, then we will integrate that with respect to x, then the limit will be 0 to 1. That we have to find out. Now, first step, when we apply the limit x, for lower limit is 0, lower limit is 0, so at 0, whole value will be 0, but at only x we have to apply it. This is 1.2 x. Now, under root, this value will give us 4x square minus x square, that means 3x square. This is x square. In place of y, we have to replace y by x. It will be 4x square minus x square, that means 3x square difference. Okay, plus this is 2x square into sine inverse. This is sine inverse. Y is x, so x upon 2x is 1.2. Okay, into dx. Now let me find out what is the solution of this. This solution is 0. Now what about this one? This is under root 3. Okay, this is square root 3, and x out, and x into x is x square. Under root 3 upon 2 into x square, because x into x1, x is from square root. Okay, so this will be under root 3 upon 2 x square, plus middle term is 2 into x square into sine inverse 1.2 is pi by 6. It is pi upon 6. Pi, because it is for 30 degree. Sine 30 degree is 1.2. Sine inverse 1.2 is 30 degree, that means pi by 6. Okay, so this is pi by 6. Now into dx, will apply before that. Let me cut this. This is root 3 by 2. Okay, now let us integrate and then apply the limits. Integration of this will be x square with respect to x. Integration is, now let me first write, simplify this 0 to 1. First is under root 3 upon 2 x square, plus this is pi by 3 into x square. Now integrate this with respect to x. Integrating this now, let me write this here. So integration of that will be, okay, this is the root 3 by 2. X square is x cube upon 3, plus pi by 3 is there, into x square is x cube upon 3. Now apply the limits 0 to 1. Limits are 0 to 1. So 1 at 1 only value will come out. Okay. This is root 3 upon 2 into 3, 6. That means 2 into 3, that means 10. X square is 1. 1 cube is 1 into 1, plus 5 by 3 into 1 upon 3. This value. What is common here? Common is 1.3 that we take. Sorry, 1.3 common. We take here common as 1.3 that we write here. 1.3 common. This is within bracket. It is root 3 upon 2 first plus pi by 3. What is the answer? 1.3 pi by 3 plus root 3 by 2. Okay. Same answer is obtained. This is the answer of question number 4. Let me write it in that way. 1.3 common. First they have written down here pi by 3 plus root 3 upon 2. This is the answer. So answer is obtained. Question number 4. This is the answer. 1.3 pi by 3 plus root 3 by 2. The same answer is obtained after integration of double integration of this or multiple integral of this figure. Okay, so triangle. This triangle is y equal to x, within above the x-axis where y equal to 0 and at x equal to 1. So this line is x equal to 1 at x equal to 1 here. This is what answer is obtained. Now let me take question number 5. So let me talk about question number 5. What is question number 5 say? Let me check it. Okay, so question number 5 is of what kind? Let me check it. Now question number 5 say evaluate. Okay, this is volume or triple integration. So triple integral is x plus y plus z dx dy dz, where the region V or volume is bounded by this, where x plus y plus z equal to a and x equal to 0. So this is the figure which is tetrahedron type. Okay, so this is the figure. Let me take that figure as tetrahedron or 3-dimensional figure. This is y-axis, this is x-axis, this is z-axis. Okay, this is origin here. If I take here, let me take tetrahedron, a straight line here. It must be a straight line. Let me take that straight line like this. Okay, the smaller one. Okay, then this is the straight line and this is the straight line. This is the tetrahedron. I'm sorry. This is tetrahedron here. So what are the values? At y-axis, we know that z is 0. What are the points here? If I substitute here, this is x plus y plus z equal to a. This is x plus y plus z equal to a. So here, what is at y-axis? Z is 0, x is 0, 0, 0, sorry. X, Y, Z. Y is A and Z is 0. This is the point at x-axis A, 0 and 0. And at Z it is 0, 0 and A. Okay, so this is here the points here tetrahedron on the axis, given axis. Okay. Now let me take a figure here, a strip, a rectangular strip. Let me take. Okay, so if I take this figure, or let me write here. Okay, this is a tetrahedron figure type, and if I take here, let me take this here. This is that kind of figure. Okay, and z-axis, this is at the z-axis. Okay, that figure. So this is equal. This is dx, dy, dz. I'm sorry. This is dx, dy, dz. Okay, tetrahedron figure. A 3-dimensional figure, I mean. A 3-dimensional figure. Okay, so if I take this strip as a smaller volume, you may say a cylindrical volume which is having this volume d.x.d.y dz. Okay, this is what we have taken. Now let me talk about what is the integration of this triple integral. Triple integral is the question number 5th here. Question number 5th, I'm sorry. Triple integral, what are the limits here? In the last limit where z equal to 0 to z equal to 0 to a minus z is a, where x plus y plus z equal to a. Okay, so z equal to a minus x minus y, z equal to a minus x minus y here. Okay, and then here it will be a minus x only in case of y equal to 0. When y is 0 here y is 0, if I substitute a minus x is value of y. Okay, so that is, and z equal to 0, from 0 to a equal to, or z equal to a minus x minus y, we are substituting value. And here it is x equal to 0 to a. So the last limit is x equal to 0 to a. 0 to a minus x and a minus x minus 1. And if this x plus y plus z equal to 1, then also we can take 1 minus x minus y. First limit 0 to that value, and then the last limit. So this is what it says: x equal to 0, y equal to 0, z equal to 0, a is greater than 0. A is positive here. So what is the value of this value? Where the region B is bounded by this value. Okay, so let me find out this region. This is the region here, x plus y plus z. Hold dx, dy, dz. And these are the limits here. By limits from this line which is given to us, x plus y plus z equal to a, we have taken these limits. First is z equal to a minus x minus y, 0, z equal to 0 at z axis. Okay, so these are the coordinates, or sorry, limits on the z axis. The y axis, second integration is with respect to y. We will integrate that. Now, in case when we are integrating with respect to z, we will consider x and y as constant. What is the integration of? Let me integrate them. So this is 0 to a. This is 0 to a minus x, and the last integral, I mean with respect to z, here we are integrating, and limits are 0 to this. First integration is x plus y are the constant into z. Try to understand. Because x plus y into 1 integration is z with respect to z. Plus this is z square upon 2 integration of z with respect to z. Limits are 0 to a minus x minus y. And this is dy dz. Sorry, dx dy. Now dz is eliminated because we have integrated with respect to z. So z is eliminated. Now putting the limits here in place of z. What are the limits? Let me write this: 0 to a minus x. Here in place of z we have to substitute these values. This is x plus y into a minus x minus y. Try to understand. Plus a minus x minus y upon 2. This 2 is out, and this whole sphere upon 2 is there. Here a minus x minus y, if I take common out of these two, that can be taken. Then for the other integration, or we can open that after multiplication. What is the remainder value that is applied? At 0, both will be 0. The lower limit is not applied, only upper limit we have substituted. Now this is dy dx dy. This is how, from the right, some people take from right hand side to left hand side. Whatever the indication of, now we will integrate with respect to y first, finally with x, so dx dy in the end. This figure is now dx dy. Okay, now let me open this is 0 to a minus x limits. Now first let me simplify this multiplication. First with x, let me multiply this. This is nothing but a into x, okay, minus x square. We are multiplying by x these three. This is x into x minus x square minus xy. Now by y, this will be plus ay minus yx or xy, y and minus y, this means minus y square. Okay. Now plus sign. This we have to open. It will be a square plus x square plus y square. All the three square, and with minus twice ax upon 2. All these are upon 2. This we are finding out with 2 divided by 2. Now, so a square plus x square plus y square minus twice ax. So this plus twice xy plus twice xy plus minus sign. Third will be with minus sign because it is minus and this is plus, so multiplication will be negative. Minus twice ay. Alright, first is twice ax, then xy, then ay. Okay, this is negative, but this is plus 1. All these values are, let me now summarize them further. This is dy dx, dx dy. We divide in the same way and we are writing this is d.x.d.y. Okay, now let me, or we can write dy dx, no problem. But we are writing dx.dy, so that is not enough for discussion. Dx can be written afterwards. Now let me summarize them. This is twice. If I write here, this is twice a square. Okay, this is 0 to a. Now before integrating this with respect to y, let me further summarize this. Now if I take here twice, it will be twice ax here, multiplying by twice, minus 2x square minus twice xy plus twice ay, this one, minus 2xy, okay, this is minus 4xy, right, further minus twice xy and minus 2y square divided by whole